Binary variables are used to model yes or no decisions, or they can be seen as indicator variables. They indicate that something is true or false. In the following, we use binary variables x, y, and z. Or, if we need a bunch of them, z1, z2, and so on up to zn, where n is the number of variables of this kind. If in such a setting x equals 1 indicates that something is true, and x equals 0 indicates that something is false, then the expression 1 minus x is an indicator of the opposite. So if we let y equal to 1 minus x, the value of y is 1 if x is 0. Or, to state it in a more complicated way, y indicates if it's true that x indicates false. It would be simpler to say that y equals 1 indicates that something is false. Therefore, the first lesson to learn is that you must pay attention to what the value 1 or 0 really means. A 1 can stand for something is true, but it can also stand for something is false. You may notice that we have already seen this in a previous video on modeling OR constraints. We had two model formulations there. In one model, a binary variable z is 1 if a constraint should be ignored. In another model formulation, a binary variable z prime is 1 to indicate the opposite, that a constraint should not be ignored. Actually, z equals 1 minus z prime, which shouldn't surprise us. If we want to express that x equals 1 if and only if y equals 1, we can simply write this: x equals y. Two other typical operators are AND and OR. For an AND, we consider two binary variables, say y and z. Let's say that we want to set a third binary variable, say x, to 1 if and only if both y and z are 1. For an OR, we want to have x equals 0 if and only if both y and z are 0. The following tables show what I mean. So this is the definition of AND. And this is the definition of OR. How can we model this when logical operators like AND and OR are not available and only arithmetic expressions are allowed in our models? Try to find a set of constraints that do the job and pause the video now. A solution would be the following. For the AND operator, we could simply write x equals y times z, which would be perfectly okay. An alternative would be to write x equals the minimum of y and z, which would work as well. But sometimes we prefer to have a linear formulation, which is a bit more tricky. For a linear formulation, we see that if y is 0, x must be 0 too. And this can be expressed like so. Likewise, if z equals 0, x must be 0. The only problem that remains is that if both y and z are 1, x could be either 0 or 1 at this point. The way to circumvent this problem is to write this. These three approaches can be generalized to more than two binary variables. Suppose that we have binary variables z1, z2 and so on up to zn, and x should have the value 1 if and only if all z variables have the value 1. Again, you should try by yourself first and pause the video now. Here's the solution. For the OR operator, we could come up with at least three approaches in a similar way. If you have not succeeded to find a solution by yourself, you may pause the video now and try again, now that you know the solution for the AND operator. Here are three possible solutions for the OR. Can you generalize this to more than two binary variables z1, z2 and so on? Pause the video now. Three possible approaches for the general case are these. When dealing with logical implications, you will often find yourself saying sentences like, if something is true, then something else should hold also. A few examples of this kind will be discussed now. If possible, we like to have a linear formulation. In its simplest form, we may like to state that if x equals 1, then y should equal 1. Note that this implication means that if x is not equal to 1, then y can have any value. Many people who are not trained in logic do misunderstand the if clause and believe that if x equals 0, then y should also be equal to 0, which is wrong. The following constraint models this implication. Of course, other combinations are possible too. What about these? Try to model it and pause the video now. This is how it works. How about these? Again, I recommend that you try it by yourself and pause the video now. Solutions may look like this. And finally, a slightly more complicated example. Pause the video now if you like to try it. This is a solution for this exercise.